Now we're going to look at another kind of function, which is a quadratic function. A quadratic function is anything that looks like ax squared plus bx plus c. We've already learned how to solve any quadratic equation equal to 0. We had 4 different methods: factoring, extracting a root, completing the square, and finally the formula. Here we're going to be more focused on the graphical behavior. So the graph of a quadratic function is what we call a parabola. It has a very distinctive shape. These are 2 examples. Okay. And there's a couple things about this parabola that are interesting. One, it has what's called an axis of symmetry, meaning if I were to imagine this on a piece of paper, I could fold the paper along this axis of symmetry, and the 2 halves of the graph would line up when I fold the paper. We think of it as symmetric about that line. The last important thing about this graph is the vertex. The vertex is that point at either the bottom or the top of the parabola. This one is the lowest point on the graph, and this one is the highest point on the graph. Notice that means that the range of this parabola is everything from this point up, and the range of this one is everything from this point down. Now, this means that if an equation happens to be a parabola, we can get information about a minimum or a maximum, which is highly useful information. Now, the standard form when we're speaking of a parabola looks a little bit different than what we're used to for a quadratic equation. The A is the same A as here, and A decides whether the graph opens up or opens down. A positive A, the graph will open upwards, and a negative A, the graph will open down. The H and K give the x and y coordinates of the vertex, which is the most important point of the parabola. Now, a nice little formula. If you happen to have an equation like this, it's a little bit harder to solve it for the intercepts or the zeros. You'd have to solve by extracting a root. It would take a little bit of work. But if you happen to have it in this form, we have another formula that will give us the x intercepts without actually having to solve it. So let's look at an example. Here is the equation of a parabola in standard form. I want the x and y intercepts, the vertex, and the graph. So the vertex is easiest because I literally can read the x and y coordinates off the equation. The x coordinate is the 4, the y coordinate is the -1. Notice I changed the sign on this -4 and I kept the sign on the -1. Because in the equation it's x minus h, but a plus k. Then the intercepts, we're going to use our new formula for the x intercepts. So they're going to be h, which is the x coordinate of the vertex, plus or minus the square root of negative k over a. 4 plus or minus the square root of 1/2. Okay. If you're interested, this turns out to be about 4.7 and 3.3, which will be helpful when we graph it. To get the y-intercept, we do the same procedure we've always done. Plug in x equals 0. -4 squared is 16. So twice 16, 32, minus 1 gives me a y-intercept of 31. This means it's such a big number, it's probably not going to appear on my graph. So now let's look at the graph. Okay. I have a vertex of x equals 4 and y is -1. That's my vertex. I have intercepts on the x-axis at about 4.7 and 3.3. And you can see the parabola that will fulfill these restrictions. Notice it is very clear that the y-intercept is going to be quite high up. This is a very narrow parabola. It will take a while to be able to cross the y-axis.